It's recording.
Alright, here's what we're going to do. By the way, close the door. Alright, here's what we're going to do. Snag it. Since you suck, I'm going to have to record you on my other computer. I got to do my audio through this thing. Can you guys hear me now? By the way, Snag it. Just to let you know, I started you to tell you that you suck. This is Snag it I'm talking to. Or the Snag it Corporation. Yes. Okay. Alright, so folks, can you guys hear my voice? Can you see my face and all of that kind of stuff? Are we good? We ready to go? Alright, let's do a recap. It's Tuesday. Oh, this coming Tuesday. Next week coming Tuesday. I want you guys to come in if you guys possibly can. I definitely want you guys to show up on time. You guys will have a class with Miss G right before that. I will... Oh, you know what's weird? I'm realizing what that buzzing sound. Can you guys hear it?
Yeah, sure.
No, what's happening is I'm talking, and then the phone in my room is talking, and it's echoing off the walls, and then bouncing back in the phone. No. Well, no, don't worry about it. We'll just deal with it. Today is just one of those days. I'll have it set up for extra people tomorrow, or on Tuesday, and also on Friday. Just because I figure maybe everyone's going to plan to come in. Anyway, two things. Once you come in on Tuesday, we're going to be covering we're going to be covering completing the square. Completing the square is a beast of a package. It's like 37 pages long, but we're going to spend twice as much time on it. And here's the thing. Miss G is probably one of the smartest people that I know because she's good at English, and she's actually really good at math. And when she was like, Brandy asked her, hey, can I stable this? She looked at it and she'd be like, completing the square? No, it was Diamond. I'm sorry. When Diamond asked, can I stable that? Miss G was like, completing the square. So, it gets you guys started off with the idea that completing the square sucks. Right? I'm saying it. Hold on. Hey. No, that's not me. That's somebody else. Someone typing.
Oh.
That's Paige.
Oh, it's Paige.
It's not always Ted. It's always Ted. No, it's not Paige. All right. So check this out. Here's what I'm going to do. The reason why most people in this world think that completing the square sucks is because a lot of teachers skip over it real quick. They're just like, here's completing the square. Learn this like this rule that's just basically take it out of my butt, pull it up on the board and say, look, memorize it. It's going to be used for the rest of your life. And you're like, oh, what is that? And here's the reason why. It's because this idea of completing the square is a stepping stone that is used for this really powerful tool that we use called the quadratic equation. I'm not going to teach you the quadratic equation yet. That's chapter 8. But what I'm going to do is I'm going to spend time really understanding this stepping stone. Because if you can understand this stepping stone, you'll get quadratic equation. Pretty cool? And if I teach it to you in the way that I think it should be taught, I don't think that you're going to think completing the square is that bad. Let's start off with some warm-up stuff, shall we? I have no idea why it's numbered that way. I didn't do it. All right, anyway. Let's try them out. Let's try problem B.
Sure.
I know. It's fine. Okay. All right, let's try problem A. It's 4.
Oh, wait, we're supposed to wait to do that?
4. Booyah. That's right, suckers. All right. 6, 8.
Liar? What? No.
No, it's not 6. Oh, yeah. Sorry. 4, 3. 4, 3, 8. But 6, 7, 9. Dude, you're so full. Is anyone confused about how to get a square root? Question? Aha. Well, if I have something like x squared equals 81, okay, and I want to get x, what's solve for x? X equals the square root of 81. When you take the square root of both sides, that's when you have to add this idea of plus or minus. Why? I'll show it to you in two ways. Here's the reason why. First, we all can basically say that 9 is the answer for square root of 81, right? But I'm suggesting to you that negative 9 also works. Why? Because the negative 9 times negative 9 is positive. Are we cool with that? I'll show it to you guys in a different way. Here it is graphic. If I'm going to get basically x squared equals 81, can I write that as x squared minus 81 equals 0? Can I do that? What did I do? How did I get from here to here? What did I do? I just put the 81 on the other side. Just subtracted 81 from both sides. Are we cool with that? If I were to graph this thing, how would that graph? I would graph as a parabola and done what to it? Moved it down how much? 81 squares, right? Cool. I mean, it's far, but I mean, you guys get it. If I were to graph it, it would look something like this, right? Where down here is 81, or negative 81, actually. We cool? But when you're solving for this parabola, how many times does it cross the x-axis? It crosses it twice. Once positive, once negative. Hence, positive 9 and negative 9. Oh, that's why we need two equations. All right, so for the most part, all I'm saying is when you take the square root of both sides, add the plus or minus, okay? And you add the plus or minus in front. So you have x squared equals 100 is really x equals plus or minus the square root of 100, which we know as plus 10 and minus 10. We cool with that? Good? All right, and then what? 11, negative 11. Online, how we doing? This whole package is not square roots, but square roots is kind of a big part of it. So I'm just kind of reminding you guys what you guys should know. We cool? All right. So now they're asking us to solve this. Solve x squared minus 4. Let's see. How would I do that? X squared minus 4. All right, just think about this. Think about it this way. I want you to think about it graphically first. X squared minus 4, what does that graph do?
Down 4.
It moves it down 4. So if I asked to solve where it crosses the x-axis, where would you say? Positive and negative 2. But let's do it their way, fine. If I want to solve this algebraically, what would I do? I would add 4 to both sides. 4, 4. Got it? Now I would simplify. Well, that goes that, and I have x squared equals 4. And then if I square root both sides, because I want to get x by itself, not x squared, I want to get x by itself. Don't forget the plus or minus when you take the square root of both sides, right? And then 2. Now graphically, I was able to think of that answer a lot quicker than I was able to solve for it. But you guys understand how to solve for it, right? How is this, by the way? Is this hard?
No.
Okay, all right. It's quite completing the square is going to start off like this, and I'm going to slowly build this concept. And if I build it correctly, you'll find completing the square not hard. Okay? I will try to make sure to explain completing the square and make it as easy as what we're doing now. Fair enough? So for all the you two talk friends, they tell you completing the square sucks. Let me teach it to you. Let me start off on the right foot and teach it to you correctly, and then hopefully you will be able to tell them, no, it doesn't suck. You just don't understand it. And then you're like, boom, deal with that. Yeah, I know. Deal with that and my tactful ways. All right, I'll tell you what. I'll do the left-hand side. You guys do the right-hand side. What I mean by that is, in this over here, I'm going to do the following for you. You guys describe, kind of write down what it is. You guys take notes on what I'm doing. All right, add 9 to both sides. Easy.
The way to do that.
All right, H2, simplify. So basically, that negative 9 times out with that. Page 3.
Page 3.
Or page 2, I'm sorry, step 3 or whatever. Square root both sides. Don't forget the plus or minus. And then what's the square root of 9? 3. Simple. Pretty cool? Shoot, writing the steps on how to do it, it takes way longer than actually just doing it. It's hard. All right. I'll tell you what. Let's beef it up a little. By the way, I'm just curious to know. Okay. We want to solve this. We can do it algebraically. By the way, online, how you guys doing? We good? Jonathan Hubbard says good. Jonathan Hubbard is sitting right next to me. He's answering online, saying that he's good.
I'm online.
Come on, like who else is online? Like Raimana, Tatiana, Thomas. Oh, Thomas answered. Ted, Paige. What's going on, folks? You guys, are you guys keeping up with what I'm doing here? That's right, I'm looking at you. All right, good. Tatiana, we cool? All right, good. All right, I'll tell you what. Why don't we solve this out manually, and then we'll try solving it graphically. We'll just think about it, okay? What should I do here? I'll tell you what. I'll do the left side. We'll talk about the right-hand side steps, and you guys can fill that in later if you want. Okay?
If we want.
If you want. Yeah, I totally know that if you want me, you're not going to do it. You know what? Yeah, I'm going to say do it. All right. But don't do it. I mean, you don't need to do it now. You can do whatever you want. How's that? But you got to do it eventually. Add 12 to both sides. I like that step, Ted, but before we do that, why don't we do it this way? Simplify. We go. Now I want to get rid of that 3. Divide both sides by 3. Simplify that. Gives me x squared equals 4. So since I have x squared equals 4, I got to take the square root of both sides. Don't forget the plus or minus, and you get the 2. Huh. That's an interesting answer. All right, let's think about how the graph would have gone. Okay? They're not even asking us to do this, but I'm just asking you guys. Like, look at this. Y equals 3x squared minus 12. What is that doing? What function is that going on there?
It goes down 12 and makes it straight.
Going down 12, swim fast plan, makes skinny by 3. We cool? So if it went down 12 and it made it skinny by 3, would you guys accept the fact that it crosses at positive at negative 2 by looking at that graph? Yeah. If it didn't get skinnier, then I would say that, positive and negative 2 is a little bit small. Okay? I would have assumed that a regular problem was kind of like this when it's down at 12. You know what I mean? But the fact that it got skinnier made you say, okay, fine, I can accept that. I mean, if you look at it mathematically, the answer is positive and negative 2, so it's got to be correct. We cool? Do you understand what we're doing here? I'm not just asking you to solve something. I'm asking you to, well, what I'm doing is, the point is, we're trying to solve for the x-axis, or x points on this graph. That's why we're doing what we're doing. Let's see. Do you guys want to do another one, or are you guys bored of this? All right, moving on then. Should I do example 4? No, seriously. I should do example 4?
Yeah.
All right, fine. I'll tell you what. I'm actually bored of telling you guys what to do. Why don't you tell me what to do? All right, example 4. Oh. 128 to both sides. All right, wait. Brandy, you're done talking. Boys, what do you do next? Fine, actually, you just put a 128 up here. All right. Yeah. Adriana says divide by 2. I like it. Yeah, you are now done talking, Adriana, for this problem.
I said that.
All right, fine. You too, John.
Oh, okay.
All right. So 128 divided by 2, anyone? There we go.
Yeah.
I got one of the twins out. Okay. Square root both sides.
Oh, wait. This is this.
Square root both sides. Well, the step here is square root both sides, but don't forget, when you square root both sides, the positive negative. The answer is 8. Boo!
I said 8.
Yeah, but you weren't allowed to talk, so I was not listening. All right. All non-talking privileges are now reset. You guys know. I mean, is this hard? Are we good? This is good? You guys feel comfortable with this? All right, cool. You want to do what? Oh, no. I want to get through all of this today. I have a lot to get through. I got to get through up to page 13 today. I know. So, watch what we're doing. All right. I got a question before I get started. Let's think about this graph. Okay, look at this problem right here. All right? Online, tell me what's going to happen. People online, come on. I want to get you guys to talk here. Yeah. All right, wait. Thomas is suggesting that you divide everything by 3. That's what I'm thinking. Or I'm not sure what you're thinking, Thomas. I have no idea what you're thinking. All right. No, but what were you saying? I didn't mean to ignore you. No, Thomas still isn't making sense. He's saying, no, it's not negative minus 9 plus 9. I still don't understand what you're getting at.
I think he's saying that's the answer.
Oh, he's saying that's the answer. I don't actually think that's even the answer. Let's think about it. What is that negative 81 going to do? Let's move the graph down 81, right? What's that negative 3 going to do? It's going to move it to the, when it's inside the parentheses, it moves it left and right. And you guys remember, it does kind of the opposite of what you think?
Yeah.
Because since it's negative 3, it's going to move it to the right 3. Are we cool with that? All right. So the graph is going to look something like this. It's going to go down 81 spaces. Oh, I'm not even going to draw that. And then to the right 3. So it's going to look something like that. We cool? By the way, I'm curious to know, if it just went down 81 spaces, what would the answer be? What would the answers be? Positive and negative 9. Yes, I agree. If it only went down 81 spaces, the answer would be positive and negative 9. But when we're moving into the right 3, we're moving both of those answers to the right 3, what do you guys think the new answers are? It'd be negative 6 and 12. That's what I think. But you know what? This is advanced stuff. I mean, I'm just asking you to sit here, look at the equation, think about the answer, and get the answer. That's not what I'm really asking you to do mathematically. I'm just saying, hey, let's just step back and take a look and remember what we talked about before. But let's see if our guess, because it's going to be our guess, right? Let's see if our guess is anywhere close to the right answer. All right. I'll show you guys. Actually, you know what? I don't even show you guys the stuff. So you guys tell me. What's going on? No, right here. Add 81. Good. All right. Now we'll square root the whole thing because the square is around that whole thing. So let's square root it. Fine. So, by the way, the nice thing about square rooting x minus 3 squared? Is it just x minus 3? Does that make sense?
No. Yeah.
The square root of x minus 3 squared is just x minus 3. Alright, what is the square root of 5 squared? 5. So the square root of x minus 3 squared, I guess I should say x minus 3 parentheses squared is equal to x minus 3. We cool with this? Yes. Alright, good. Alright, and by the way, the square root of 81 is positive and negative 9. We cool?
Yeah.
So you're telling me that x minus 3 is either positive 9 or negative 9. That's what you're saying. Right? Now, how do I get rid of how do I get x all by itself? I just want x, just x. I add 3. There we go. I add 3. So this is 12, and this is negative 6. Oh, snap. That's what we get. Dang, we're smarter than we thought we were. Well, maybe Diamond's smarter than we thought she was. I don't know if that's a compliment. Is that a compliment?
No, I don't think it is.
Wow, Diamond, you're smarter than I thought you were. Okay, I should not say that because that was very nice. All right. Are we cool with this? Do you guys understand how this stuff works? At least, if you didn't understand how we did it graphically, if you at least justify why that might be the correct answer, and you see, oh, I see how it works. We cool? All right. Because what I'm doing actually here is when I'm making you think about the graphs, I know that this section right here is going to talk about like solving it, and I know that the next section right is going to talk about graphing it, so I'm kind of doing both the same. By the way, Elizabeth, I started off my class with talking about how you're one of the smartest people I know. You weren't here to hear that comment, so I'm just going to say it again. Well, I don't know. What I'm saying is, did what I say, was that even a compliment? I'm wondering. Like, I said Miss G is the smartest person I know. She knows English, and she's actually really good at math too. Because I am good at math, and I suck at English. That makes me not necessarily that smart. But then I said, and the reason why I brought that up is because when I said found out we were learning about complete the square, you went, and basically I'm saying like, and then I basically went on to say that everyone who does that probably didn't learn it the way it should be taught.
Oh, guaranteed.
And I think it's so what I'm doing is I'm spending 2 weeks just on that.
I think that's an excellent.
And I think that most math teachers give you 2 days, and basically if you do all of this stuff in 2 days, it feels like the teacher's just pulling this magic steps out of his butt, throwing up on the board, say, memorizing for the rest of your life. A, I don't want to memorize anything that came out of that area. And B, I'll never memorize it because it won't stick with me. I mean, maybe it came from that area, it might stick, but I'm just like, I don't know. All right, anyway, let's move on. You ready?
Ted's mother is very good at English. She is smarter than I am.
But apparently she's not that good at math. According to Ted. Anyway, apparently you guys are friends too.
Yes, I am friends with
Yes. All right. All right, I'll tell you what. I'll give you guys 1 minute. Try example number 6. Ooh, you guys are like on it. Let's see how far you guys can get through example number 6. Oh, yeah. Excuse me. All right, those of you online, actually, you know what? I'm going to do something a little different today. Tatiana? No. Tatiana, do you mind? I know this might seem a little weird, but do you mind? I'm gonna put on people's what you call it, cameras.
I'm not in here anymore, Mr. Dalda. I'm gonna leave.
John, why are you afraid of turning on your camera when you're sitting right in front of me? Well, I can't turn on your cameras without you. Well, actually, I can. But I mean,
what?
No, it's creepy.
Why?
Are you serious?
Okay.
Yeah, that was weird.
I did not do that.
Raimana,
I have the camera on.
or no, Raimana, I always see your face. Tatiana, can you turn on your camera? I want to feel like I'm talking to somebody here.
Right here.
I know. I'm not saying that you're not people. What I'm saying here is I want to make sure that I want to see other people as they were.
Everyone say hi.
Hey, there's Raimana. Or at least Raimana's mouth.
That mustache, though.
I thought Tatiana turned on her camera. Alright, it's alright. Tatiana, if you don't want to, don't worry about it.
Just only turn everyone's camera on.
There's Ted. Good looking, Ted.
What?
You look like you're wearing like a really bright pair of sunglasses. Oh, there's Ted. Is that Ted?
Hey there.
What's going on, Ted? How you doing? Anyway, how are you guys? Are you guys done with this problem?
Oh, good. Oh, wait, I stopped.
Oh, excuse me. Alright. Well, why am I looking at one? You guys have the same answer.
She copied me.
What'd you guys get?
I wasn't done.
Positive 18 and negative 8. Is that what everyone else got?
Yeah, guys.
I'm almost not going to bother to do this problem. In fact, I'm almost not going to bother to do this problem, but I'm not going to do this problem. I'm going to just assume that you guys got it correct. I have no idea. Okay, fine, I'll check. I think I did that example on my thing. I'll look at my notes.
So look at Jonathan.
Mine was done.
Alright.
Yeah, no.
I have a question. Did everyone get that at least? Can you do that on your own? Positive 18, negative 8?
Yeah.
Okay, if you can't, you can let me know privately. Or something. But I'm just... Shh. If you can't, just let me know. That way I can make sure to go over it with you. But for the most part, don't worry about it. Actually, John.
Oh my god. Thanks, Mitchell.
Gee, you're just a bad
What?
Alright. I'll tell you what, this thing looks a little bit more beefy.
Yeah, I felt that.
Let's do this one, ready? I'll do it for you.
Why?
Huh? Why am I going to do this problem for you? Alright, fine.
Yeah.
It's not that I don't want to do that, though. I want to give you guys an opportunity to make sure you guys can do it on your own. But here, why don't I do this for you? Alright, here, fine. I'll tell you what, if you guys can do it faster than me, to beat me.
Wait, what? Wait.
I'm doing problem number 7. And you guys can do it on your own if you want. I'm going to talk through it. Add 48 to both sides. You better not go slower than me, at least. Add 48 to both sides.
Wait, I need a calculator written down. It doesn't count.
Get rid of that 3, so let's divide everything by 3. 48 divided by 3. Oh, wait, what is 48 divided by 3?
Don't tell guys.
It's 16, Mr.
Hey guys, online, what's 48 divided by 3?
Mr. Dalton, it's 16. I hope you're out. You're a mic here.
It is 16.
Square root of 16.
I
can't jump
Square root of 16 is 4.
I'm done.
I got it wrong. So, let's see.
Don't get it wrong.
X plus 4, so that's 6, and negative 2? Is that what you guys got?
Mr. Dalton, I failed.
What's going on, Raimana? I can see his mouth. There we go. That's him. Apparently he feels sick. Is that what you guys got, by the way? Positive 6, negative 2?
Yeah, I got positive 6, negative 2.
Alright. I'll tell you what, let's go to Desmos. Let's try to throw this in the graphing calculator.
This guy is...
Mr. Dolbe,
Yo.
I believe it is negative 6 positive 2, because if you looked at it, it was minus 2.
Yes, I agree with what you're saying, and then I disagree with what you said entirely. In order to get x all by itself, you need to add 2 to both sides. So therefore it is positive 6 and negative 2.
Oh yeah. Forgot that rule. Oh well.
Yeah. Don't worry about it. But you know what? Call me on things, dude. Like, if I'm wrong, totally call me on things. And don't think that you're being a punk. If you're being a punk, I'll tell you that you're being a punk. Alright. But I can put the camera back on us.
No, put it on someone else. We'll press the button. So that you can put it on anyone's else.
Alright. Why? Because John's the other one. There's 4 people. John's the third person. Why put it on John? John's sitting right there.
They wanted to see me twice.
No, I'm not requiring you guys to turn on your cameras. I just want to feel like it's a social environment. Anyway, what are we doing? We're doing 3 times x minus 2 squared. Am I graphing this right?
Minus 48.
Minus 48? Is that right?
Equals 0.
Alright.
Well, if you wanted to do that.
But we don't need to put equals 0. What we're going to do is we're just going to like this. Oh, I can't even see what that is. Oh, hey, look. Where does it cross? It crosses at negative 2 and positive 6. Boom, we graphed it.
Oh, wait, no.
If you want to think about how it works, you kind of think about it like this. Okay, fine. You moved it down 48. You moved it to the right 2. And you scrunched it up at factor 3. You don't need to graph it, by the way. I'm not going to do the next example problem. I feel like it's a waste of my time, it's a waste of your time. I'll tell you the answers, though. It's 16 and negative 10. Yep, that's the answers. And I apologize. If you guys really want me to go over it, please let me know. If you guys try that example on your own and don't get that, then you've got a problem.
You've got a problem.
Yeah. That's your problem. You deal with it. I like that. That was very nice of me, but I'm sorry. It sounds like a personal problem. I wonder if I offended anybody. Oh no, it's just King's Go. Okay. I wonder if I ever say sounds like a personal problem. You should get that checked out. Alright, anyway, let's try this one. I realized I didn't print out these graphs, I'm sorry. Let me go look for this thing. We're on page, I don't even know, page
11. What is that?
7. Apparently, I didn't think that this was that important. Well, no, it is important. It's just
16, yeah, Mr. Dolly got it correct.
What is that?
You got the example right.
Oh, you're working out the example problem that I didn't do?
Yeah.
And you're realizing that I did it right when I didn't do it? The one I didn't do,
You probably did it before.
Of course I did it beforehand. I can't do that in my head.
Oh, you did?
Yeah. You guys think I solve out these example problems just off the fly?
So you did do it.
Actually, yeah, I did. I did that quite often. But I do have quad 7, and I have it printed out. So most of the time, I actually prep for the class that I'm going to teach.
Okay, since leaving.
But sometimes, I don't. And you know what? Okay. Alright, by the way, here's the graphs I should have printed out. Let's take a look at them. I can barely see them. There we go. Oh, there we go. This one. Here we go. Alright, good.
What page is that?
I can barely see them. Can you guys see them?
Wait, isn't it in our agenda?
It looks like a what?
Oh, yeah.
You like math?
Only if I always do it.
That's fair enough.
I
What if you don't know how to do it? You guys don't like math?
Nope.
What if you don't know how to do it and it's only temporarily that you don't know how to do it?
Well, if I get wonderful at it in minutes.
And then you'll be like, I can get good at this if I, work on it a little bit. Would you like it after you get good at it?
Yeah. Question.
All right. Anyway, let's talk about this. In fact, I don't need to even. I'm not even going to really go over. Like, I'm not going to make you. I want in class right now. What I'm going to do is I'm going to make you guys just talk to me about it. Let's take a look at this thing right here. See this graph right here? See this dotted line right here? Yeah, see this one that has like a lot of dots next to it? That's the graph of an x squared function, right? That's a parabola. What did we do to it to make it this one? Negative x squared. I just added a negative there. That's what you should write here. Adding negative. What does it do? Flips it over. There we go. Whoops. Flips it. We're not meaning that in an offensive way. We're just saying it actually flips it down. In fact, if you want to give an example of that, you can just draw a graph like that. Oh yeah. We cool? Alright. Let's take a look at this one. This one right over here. Alright. Look at this one. See this thing right here?
I moved it to the right.
I moved it 2 to the right. How did I do that? Negative 2 where? Negative 2 inside the parentheses. Alright. What about this one right here? X plus.
Yeah.
Yes, it's positive 2 in the parentheses.
Wait, Mr.
All right.
Can you go back to
This last one?
Oh, okay.
So I think the graphs I should have shown you is this. Look at this graph, and look at this graph. But then you guys can write in your own rules as to what that did.
Draw it too?
Yeah, sure, you can draw it. All right, Ted, I'm confused as to what you're asking me to do. Oh, I'm sorry, here's the graphs. And then you guys can write in a minus inside parentheses moves it blah blah blah. And I'll let you guys replace the blah blah blah. Right, you guys understand what's right here, right? I'm just too lazy to do it. All right, good. A plus, ditto, 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 moves it, blah, blah, blah. Write your own notes. Go for it. I mean, as long as you understand it, I'm actually more impressed if you guys understand it. So if you write everything down. All right. But by the way, that doesn't go for turning in your homework. You guys can't just tell me, I understand my homework, I'm not going to turn any of it in. Because I'll still give you guys math and say, well, they understood it. Alright. Can I do the y squared instead of x squared? Okay. Ted's asking, can I make it y squared instead of x squared? And what that will do, Ted, is it will just turn our parabola 90 degrees sideways. That's something I just don't want to deal with right now. It's not that hard. Because all you got to do is basically turn your head this way, and then everything works out. But for the most part, let's just kind of, keep with what we got.
Is it possible to turn the graph of
Yeah, it's where you use a y squared instead of an x squared.
Oh, I knew that. I was totally paying attention.
All right. By the way, I'm not even going to show you what the graph looks like, but I'm going to ask you this. X squared plus k, what does the k do?
Wait, is k replacing a?
K is not replacing a. What are you saying, a?
Well, I mean, like, or up.
It moves it down or up. So the plus k does what? Plus k moves it up. If I want to draw an example of that, just draw a parabola up going. I mean, just push up. What do you want? There we go. Minus k moves it down. There we go. It will. It will. In fact, you know what? Actually, I really don't think it's that difficult. I'll tell you what. If I only gave you guys one lecture to cover this, and I just went through it, you would have found this difficult. But I'm giving you guys 4 lectures to do this. I'm kind of starting off. Basically, this is the basis behind the idea of complete the square. It's basically all I've been doing is a recap of everything we've done before, right? I haven't really touched any new material here. I mean, all I'm doing is I'm combining a lot of the stuff that we have learned before. But if you've learned what you learned before really well, then you don't need to really worry about then this stuff should be easy for you because it's just a recap. We cool? All right. And I guarantee you that this is the stuff, if you get good at this, then you're going to be good at completing the square. And since I'm allowing you guys extra time to kind of really understand it, that's important. All right. Anyway, so we understand how to do the transformations. We also understand how to combine those transformations. Like, for example, all right, given this, let's combine all of the stuff that we know. How do I graph that? What would I do?
Move it up 2.
I'd move it up 2, then I'd flip it. All right? So if I were to ask to describe how the parent function f of x squared is transformed, you just say, all right, that parent function is pushed up 2, flipped upside down. Done with that one. All right. State the coordinates of the vertex. Where's the coordinates on this thing right here, x squared? Where's the vertex? Just think about the regular parabola. Oh, oops. It's at 0, 0, right? Now, what did I do to make my parabola? I moved it up 2. And I flipped it. Flipping it doesn't change the vertex, right? The vertex is still the same. It's just upside down. But moving it up 2, that changed the vertex. All right, so it's 2. What's 2? The y or the x? The y. Because I moved it up 2. So your vertex is 0, 2. Are we cool with that? All right, sketch the picture. Done. Fine, it's ugly. And I'm doing it in a different color.
The vertex was so conscious. Okay.
Booyah! I did it.
Really high for +2.
No, my scale is this is 1 and that's 2. You like it?
A little higher than normal.
Yeah.
Hey, all right, fine. Let's take the time to do this. You guys, we're good. You guys really want? I'll make the graph real nice. All right. Find the x-intercept. Where's the x-intercept?
Probably 1, -1 and 1.
It's right there.
Oh, it's -1 and +1.
It's all right. I'll tell you what. To be honest with you, it's a little bit harder than that. What you would do is you would say, all right, fine. When I want to find the x-intercept, what do I do? Y equals 0. There we go. Or actually, in this case, g of x equals 0. It's basically the same thing, right? So you're saying that 0 equals -x squared plus 2,
Exactly the same.
which is the same as x squared equals 2,
So I'm wrong.
which is
Yes.
x equals positive negative the square root of 2, which is 1.41.
1.4.
Positive, negative.
You know that.
All I did was I set it equal to 0, and then I got x all by itself. Write it down if you need to. Actually, I think that they give you let me look down real quick. Oh, yeah, they actually gave you space to do it. Let's do it here. The original function was x squared minus 2 equals y or something like that. or I'm sorry, it was y equals x squared minus 2. Or no, negative x squared minus 2, right? That's what it was.
Plus 2.
X squared plus 2. All right, sorry. All right, so what I told you guys to do was set it equal to 0. Negative x squared plus 2 equals 0. Okay? Actually, that's what the boys told me to do.
You
said set equals 0, right?
Y equals 0.
And then negative x squared equals negative 2. Are we cool?
Wait.
Positive x squared equals positive 2. You see what I did there? Huh? Are you just saying yes or no? You actually see it? All I did was I just kind of got rid of the negative signs. They're all 2's, yeah. And I took the square root of both sides. And the square root of 2 is not a pretty number like we've been used to working with, but I'll tell you what, you guys get to use calculators on your homework. Do you guys know that?
Yeah.
All right, good. Use calculator. Use a calculator and you'll get x equals plus or minus this 1.41. Did I even write that down somewhere? I don't think I did. No, I know, but I mean, I don't think I worked that problem out before. I just know that the square root of 2 is 1.41. It's just something you should know. It's something that you'll figure out eventually. I'm not telling you to memorize it, I'm just saying. After doing math for like 20 years, I can learn the square root of 2. We cool? Would you guys agree? I mean, look at the graph. And look, Jonathan. It's a pretty graph. There's the pretty one. All right, here's the pretty graph.
That was nice. I mean,
Don, you're the one who's giving me a hard time on making another graph. Anyway, look at where it crosses. Look at where it crosses. It crosses right here and right here. Would you guys agree with me in saying that that could be about negative 1.41 and 1.41?
The graph is not pretty yet. It does not have a bird on it.
Okay. Drawing a birdie.
You guys are so mean. You know what?
Grab the parrot on the top. No.
You guys.
I don't like that one.
Too bad, John.
I can't believe we did. It's so rejected.
Now I've pleased everyone. But I have said that my graph is not pretty yet because it doesn't have a bird on it.
I like Transformers though.
So I put a dang bird on it. And then I started drawing a bird, and you guys are like, that's not a pretty bird. I don't understand what that is. So I looked up pretty bird on Google. Google pretty bird on it. Hey, deal with it.
Okay.
Alright, we cool? You guys having fun? You guys understanding what's going on? Alright, good. Alright, let's do example 2.
Wait, Mr. Jonathan, we're spending 2 weeks on this packet. We're already up to page 10.
Yeah, I know.
Oh.
I need to get to page 13 in the next, 20 minutes. Alright, let's do this. Page number 2, or example 2. In fact, I didn't do example 1 very well. I just kind of, talk about it. But let's actually do this one.
Wait, what?
X minus 2 squared minus 1. Okay, fine. What this is asking is, describe how the parent function is transformed. Dude, give me your phone.
Dude.
Alright, fine. What do you need in a calculator right now? All I'm asking is, what does the x minus 2 do? What does this part do?
Right, dude.
Okay, write that down on page whatever page. On page whatever. Moves to the right 2. What does this do? -1. Move down 1. Are we cool? Think about where the vertex going to be. Yes, that's actually mostly true, but no, I mean it's mostly true. In fact, if we were solving it using factored form, that would actually be how you would get it. But
it would be -1.
It would be -1. What would be -1? My vertex would just be -1. I need it's a vertex that has 2 points. It has points.
No, I got it. It's at the tip of my tongue. 2 and -1. 2 and -1.
All right. We got here's what we got.
Oh my gosh, he's making a challenge.
Diamond's side is 0, -1. John's side is 2 and -1. No, that's what I'm saying. I asked where the vertex is.
Oh no, I was done.
John said, Diamonds jump ships. I was going to ask you guys to fight. I was going to say, throw it down, dude, and whoever wins is right. I was kind of betting on John for that because I knew he was right. So, but anyway, whatever. All right. I have a question. Why? Why is it 2, -1?
Because it moves to the right too.
Because my vertex originally, my parent function is at 0, 0, right? And you told me to move it to the right 2. Okay, fine. My new vertex is at 2, comma 0. They move it up or down, I just move it to the right 2.
To the right.
Yeah, so I moved it to the right, to the right. Everything you draw in your problem goes 1 down. So it goes 2 to the right and 1 down. I know.
Wait, who was that?
I guarantee you guys are going to take this archive, put it on YouTube, and take that little snippet and make a song out of me. Yeah, something like that. Anyway, your vertex is 2, 1, or no, 2, -1. I'm sorry. Does everyone understand how to get that?
Yeah.
All right. Let's get the picture. They didn't give us a nice, pretty picture to use. Fine, John, I want to see you draw a nice little picture.
Oh, what? No, I didn't say
That's mine.
I can't even draw a straight line.
Alright, so I'm guessing that that's 2 and that's 1. That's what mine looked like. Where does it cross? Where does it cross x-axis?
Probably.
It looks to me like 1 and 3. How should we solve this? Let's solve this like we were doing before. Let's say x minus 2 squared minus 1 equals 0. You guys understand what I'm doing here?
Yeah.
Alright. X minus 2 squared equals 1. X minus 2 equals plus or minus 1. Yeah, I'll slow down for you. I'll let you digest that.
Oh, wait.
Do you guys understand what I did? I took a few steps.
Yeah.
Kinda. Ish.
What don't you understand about it?
This is the confusing part.
X equals 2 plus or minus 1. So that's telling me that x equals 3 or x equals 1.
Got it.
Everyone agree? No, write that down, because I skipped a bunch of stuff on purpose. Digest it. I hate it when my teacher does that. I have a teacher, and he just burns through it, and he's like, done with class. See you, suckers.
Does he really say that?
No, but I feel like he says that sometimes. That's a 2 plus or minus 1.
Really bad.
Boys, you guys understand what I did here?
Skipped over the square. Oh, wait.
I skipped over the square root because the square root of 1 is 1. But I still have to add the plus or minus because technically I did square root both sides. That's what that step was there. Then what I did was I added 2 to both sides, equaling up. And I have either 2 plus 1 equals x, or 2 minus 1 equals x. So 2 plus 1 is 3, and 2 minus 1 is 1. We good?
Yep.
But I could have looked at the graph and kind of showed you that. 3 more pages. And what are those 3 more pages? There's another example problem, and then some practice problems. What page is this? This is 12, this is 13. All right, let's do this. Let's talk our way through this example problem. And then what we'll do is we'll do the last part on, we'll do the bottom of page 12, which I don't know if it's your homework or not.
Too bad we're doing it.
But if it is your homework, I guess I shot myself in the foot there, and then we're done. Sound good? Sound fair?
Yeah.
All right. Talking our way through this example problem. Cool? By the way, Tatiana and Ted and Thomas, actually Ted, Thomas, and Ramona, I usually hear from you. I want to make sure you hear from the whole class, all right? Hey, you too. Jump in on the conversation.
She hasn't talked to the whole class.
Okay. All right, negative 2x plus 2 squared minus 4. There's a lot going on here. Let's dissect this thing one by one. Let's take a look at what does this plus 2 do? Online, I want you guys to tell me what happens. I know you guys know the answer.
Mitchell got all of them.
This is your version of talk, chat, and French.
Yeah.
It moves at 2 spaces. No, he's right. It does move at 2
You
spaces.
need to specify. Yeah.
All right. The face guys are asking you to specify. Please clarify. Thanks, John. It moves it to the left.
Okay, I'm sorry.
How many times does it move to the left? 2. Technically, it goes to the left, to the left. Ooh. Oh, okay, fine. All right, fine. All right, so it moves to the left. Are we cool with that?
Yeah.
All right. See this 2 right here. I want somebody else online. Tell me, what does that do? Actually, you know what? Twins, why don't you tell me what it does? See this 2 right here?
Alright, so.
Oh, there we go. Ted's got it already. It makes it skinny. Makes it skinny by 2. All right, cool. What about this negative, boys? See that negative? What does it do? Flips it. There we go. All right. Now I'm gonna ask this. I'm gonna ask this, and this one's Paige and Tatiana. I'm calling you out here. What does that do? What does that negative 4 do? I'm not gonna. Oh, okay, there we go. It was Tatiana that said that, right? Good. Moves it down 4. Love it. Exactly. There we go. You guys got it. All right, good. Where's the vertex?
Negative 2, negative 4.
Boom. You got it. Negative 2, negative 4. You can kind of look at this number right here and this number right here. Negative 2, negative 4. Sketch a picture. Fine, let's do it. It moves it to the left 2. It makes it skinny. flips it upside down, and moves it down 4. So 1, 2, 1, 2, 3, 4. You guys agree? Something like that? Alright. What are the x-intercepts? Do you guys understand how dumb that question is? When does this thing cross 0? It never crosses it. No, what we mean here, that not all parabolas have a solution. When you're given a parabola, there's not a guarantee that you can find, values of x. Because maybe the thing doesn't cross x at all. So if you guys end up getting stuck, it's not necessarily always because you're wrong. It just might mean that the solution doesn't exist. You guys understand? Cool? Alright. Alright, that's it. That's pretty much.
That was page 11?
That was page 11.
Oh, I didn't understand. One more.
Alright.
Function is here.
Well, you can't set the function equal to 0. You set the function equal to 0. If you set the function equal to 0, it'd be equivalent to trying to find the x-intercept. We skipped that step because we realized that there are no x-intercepts to begin with. We cool? Alright, let's just stop this off, because I almost feel like you guys will be able to go through this pretty quickly. Look at the function. What's the vertex?
Oh.
We're done. I'll tell you what, you don't even need, you can leave if you want, but we're done. But I'm going over all of these problems on page 12. And +3. I don't know if this is your homework, or part of your homework, but if it is your homework, not bad. Boo-hoo. Alright, I want a different person to answer these questions.
Number 2 is 5 and 8.
Alright. So, John says number 2 is positive 5, negative 8. There we go. Alright, what's the first one?
0, 3. 0 and 3, yeah.
0, positive 3.
That's your one.
I like it. Wait, John, Mitch, you guys aren't able to answer.
Oh. Can I just do it on my paper? Yeah, just do it on my paper.
No, it's fun. I want everyone to.
Wait, I'm confused.
Well, you're wrong. You're a little bit more wrong. Oh no, that's fine. That's fine. Why don't you guys discuss it with them and see what you guys can come up with? No, you don't need a square root 8. You don't need a square roots.
The answer is in the.
You can look at this and literally tell me what the vertex is right now. And I. Close. Very close.
Wait.
No. 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 Negative 8, negative 2. Alright.
It moves from the left 8 and then down 2.
Well, no. But you're right. And here, look. Let's look at this. What's going on?
I'm gonna leave them with everyone.
I know. Alright, fine. Let's look at that. What's going on? Alright, so you moved it to the left 8. Right? And then you moved it down 2. And then you made it skinnier, but that doesn't matter. I know. The vertex is the same, but you made it skinnier or whatever. Even if you flip it upside down, that doesn't really change anything. You flip it upside down, make it skinnier, make it fatter, it doesn't change the vertex. The only thing that changes the vertex is these two numbers. This guy and that guy. Go for it.
No, I can't.
Diamond did it. 8, 5.
Are you looking at?
No, I already wrote it down. I'm just
Yeah. Boom. -5, -16.
You guys all get a gold star already.
All right, someone online. Come on, give me an online.
So what?
Online. For number 6, what is the answer? No. I know you guys get it.
We're forbidden.
All right, Tatiana says negative 8, positive 7. Tatiana, that is so close. Positive 8, 7. Because remember, it's the opposite of this sign right here. Because that sign moves it right and left. And remember that moving it right and left does funky things. This technically means go to the 8 right 8 spaces. So it's positive 8. Does that make sense, Tatiana? But on the K value, this one right here, this actually tells you literally move it up or down. And that isn't a backwards kind of deal. So this answer is positive 8, comma, positive 7. Cool? Paige, I want you to give me one of them.
I don't even know she's at a computer.
Don't worry about it. I just want one of them. I'm not trying to put you on the spot. If you need help, just ask your classmates. And I'll tell you what, if she asks your classmates, don't tell her the answer directly, but kind of help her, guide her as to where it goes. Right, because you guys know my style by now, right? I don't ever teach you the pattern. I just make you do enough problems so that you guys figure it out.
Now you just make us do it.
Okay, Paige says she needs help. Can you guys tell her how to do it without giving her the answer?
That's impossible.
No, I've been doing that the whole time. You can. All right, talk to her. Here. No, I'm serious. Your classmate is asking you for help. And I'm sure that you guys can empathize with feeling the need for help.
One thing to know the answer though, are we going to try and know how to do it?
Yeah, we're doing number 7.
Okay. Oh. Okay, so like,
Hey, can you hear her?
Paige.
Our voice is like. Paige, is this better? Try to talk to her.
Can you hear me, Paige? Paige. Paige.
See, this class is fun, but I'm sure this class is not fun.
Can you hear the words?
I can't hear.
Can you hear the words coming out my mouth? Can you see my?
Paige is asking a serious question. I want to make sure that we all. Okay.
Can you take the turn?
Paige, can you hear my voice now? Can you guys hear my voice? Can anyone hear my voice?
What is happening?
Okay. All right. Paige's connection might be a little bit bad. But, all right. Why don't you guys tell me what to type? I'll type it out. Actually, you know what? Mitchell was commenting about how slow I type. Why don't you tell Mitchell what to type? Okay, Mitchell's typing on Jonathan's computer. Just letting you know. All right. I want your classmates to help you guys out. I think that's important. I want you guys to feel like it's you as a team versus Mr. Dalday. So, go for it.
Maybe you can hear it already.
All right. Okay, we're chatting to you kind of the idea of what's coming. Oh yeah, I'm sorry, Paige. There's no real point in saying yeah. All right. Or are you? Because I'm waiting for you to like watch you read or. Okay. All right. Here's what's going on. The negative 16. What? Oh yeah, you're right. I asked you. In fact, I actually have to go. So I have to leave. You guys can stay and chat with her. Okay. All right. All right. I'll tell you what. I want you guys to explain that to her. If Paige, if you still need help, let me know. But I want the classmates to help you for now. All right. I know. She says she's going to be in here next week. All right. I got to go. I have class at 11. Right here.
Halfway through.
Oh, got hurt. Where's